In the last session, we have uncovered introduction to Java, important or key points about Java, introduction to data types. We have also covered what is statically typed programming language and what is dynamically typed programming language. And we have also discussed a sample employee management system and why mobile number should be a string and not a number, and how we can pull the employee details whose mobile numbers ending in certain numbers or starting with certain area codes. And we have also discussed that we have two kinds of data types, primitive and non-primitive in Java, and converting from primitives to objects and objects to primitives. So let's discuss more about primitive data types or fundamental data types. Following are the basic fundamental data types Java. Number one, integers. And they can be from negative infinity to plus infinity. Number two are real values, which are in the form of x, y, where x and y are integers again. Then we have characters, which are ASCII code or Unicode. We'll discuss what these are in a bit. The fourth one is Boolean, which are essentially truth values, either true or false. What is ASCII code? ASCII stands for American. Standard for information exchange. C and C++ uses ASCII, and its range is 0 to 255, and it includes English alphabet. Unicode is universal code. It includes all languages in the universe, and Java uses Unicode, and its range is obviously more than ASCII code because it includes all the languages in the universe. Now let's see some rules or principles how we can choose the data types. Let's say I have an integer a and its value is like 1, 2, 3. I have an integer b and its value is like a big number. So let's answer some questions here. Question number 1. A and b are integers. Yes or no? Yes. Question 2. Which variable or container takes more space? A or B? B is the biggest one, so B will take more space. And which variable or container takes more time to access? A or B? Obviously, B is the bigger one. It takes more time to access. So here's the question. For example, we have 3 members in a family and they live in a 2 BHK, which is good or recommended. Say another family with again 3 members lives in 5 BHK, which is allowed or okay, but not recommended. Why? Because there is a waste of space. Similarly, based on the space constraints, data types are further divided or segregated for optimal use of space or memory. In other words, so integers is divided into 4 types. Byte, which is the smallest. If it is bigger than byte, then you go for short. If it is bigger than short, you go for int. And if it is bigger than int, you go for long. We will see how big are these data types in a while? Now, next one is real values, and they are divided into two categories: smaller ones, float, and bigger ones, W. Then we have characters, and character is just single type, which is char. Then we have Boolean, again, it's single type Boolean, either true or false. So in Java, we have total 8 primitive data types. What are those? Int short, sorry, byte short, int long, float, double, char, Boolean. So let's see what are the wrapper class for these primitive data types. In the last session, we discussed about wrapper class. For each primitive data type, there is an equivalent wrapper class. The first primitive data type is byte, and its wrapper class is uppercase B byte. B is uppercase since it's a class, so short, its wrapper class is uppercase S short. Then int, its wrapper class is uppercase integer. Then we have long, and it's uppercase L long. Float and uppercase F double, uppercase D double, char, uppercase C character. Then the last one, Boolean, uppercase B, Boolean. So for every data type, we need to understand some special properties. What are those? Data type name. Then what is the keyword for that data type? Then wrapper class. Then size of the data type. Then range. Then what's the default value of that data type? So these are the properties which we need to understand for each of the primitive data types, which we will discuss one by one here. The first one is byte data type. So byte data type, the data type name is integers, and keyword is byte. Then the wrapper class is uppercase byte. Then the size is 1 byte or 8 bits. Then range is -1 to 8 plus 1 to 7. And default value is 0. So let's try to understand how we got this range. We have 1 byte or 8 bits. So the lowest can be 0, 0, 0, 0, 0, 0, 8 zeros. And the highest can be all ones. And this is called as most significant bit. So what does that mean? For example, if the most significant bit is 0, then it's a positive value. And if the most significant bit is 1, then it's a negative value. And but the lowest or lower range number we need to take the most significant bit as 1 because the lower will have negative. So then now let's rewrite. The most significant bit is 1 and the rest of them are zeros. This is the lowest value in the range, and this is the highest value in the range, and the most significant bit for highest value should be positive, which is 0. So if I have to rewrite the highest value, then it should be 0, 1, 1, 1, 1, 1, 1, 1. Now let's calculate this. This is 2 to the power 0 into 1. This is 2 to the power 1 into 1. This is 2 to the power 2 into 1, 2 to the power 3 into 1, 2 to the power 4 into 1, 2 to the power 5 into 1, 2 to the power 6 into 1. And we need to add all of these values. Let's see here. 2 to the power 0 into 1 is 1. Then 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16. So let's add until here. 10, 20, 21. It's 31. Then we have 2 to the power 5, which is 32, plus 2 to the power 6, which is 64. Let's add this, which is 6, and 9. So let's add 96 to this 31, which is 7, 12, and the most significant bit is 0, which is positive, and this is the highest value. Now let's calculate the lowest value based on this. So for uh, most significant bit 1 and all others are 0. 1, 2, 3, 4. Yeah. So most significant is 1, which is negative. We need to do 2's complement. And 2's complement is 1's complement plus 1. So let's do the 1's complement first. We don't consider the most significant bit. So what's the 1's complement of 0? 1, 1, 1, 1, 1, 1, 1. And then we need to add 1 to this. So it's going to be 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So we have this as the low value. So 2 to the power 0 into 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, all into zeros will become 0, and this is 2 to the power 7, which is 128. And what is the most significant bit? 1, which is negative, so minus 128. So this is how we derive negative 128 range for the byte. So obviously we don't need to remember how we calculate the range for this data type or for the other data types which we are going to uncover. But this is only for our understanding how the range is calculated based on how many bytes or what is the size of the data type. This is how the range is calculated. This is only for our understanding. And obviously we have some methods to derive these values. We don't need to calculate manually. Let's see how that happens. So now, to get the uh, range, we have a function which is wrapper class dot in value and wrapper class dot max value to get the range for any data type. So let's see how this works out. For example, I have the sample Java program and I want to get the range for byte and min underscore value, and I'll also get the max underscore value. Don't worry if you don't understand this program, we will uncover as we progress. For now, just let's print the min and max values for byte data type. For compiling the code, we use javac space the Java file name, and then to execute, we use Java space test. And if you see here, got the got the range from this program, and minus 128 to plus 127 for byte data type. Okay, now let's move on to paste this program here and also the result. For the byte data type. Now let's see what is the next data type, which is short. And the data type name is integers. For keyword, it is short. The wrapper class, uppercase S short. Then the size is 2 bytes, and it is going to take 16 bits. And range, even I don't know, let's just calculate it. We need to just change the data type name, wrapper class name, basically short, and let's compile, and then let's execute. So the range is minus two plus and default value is again 0. The next data type is integer data type, or int, int, and it is also integers. The keyword is int. The wrapper class is integer, uppercase I. Then the size is 4 bytes or 32 bits. And then let's calculate the range for int, which is integer. Let's compile, and then this is the range for integer, -2, positive, this much. And the default value is 0 again. Let's see the next primitive data type, which is long. And the data type name is integers, and the keyword is long, lowercase. The wrapper class name is uppercase long, uppercase L long, and the size is 8 bytes, and this is the biggest one in the integers. And it is 64 bits. Now let's calculate the range for long. Let's change this to long and this to long. And save it, compile, and then execute. This is a huge range for long. negative this much too, positive this much. Now let's see the next primitive data type, which is float. And data type name is real values. The keyword is float, wrapper class is uppercase F float, size is 4 bytes. Or 32 bits. Let's see the range for float. Let's execute, compile, execute, and this is the range for float. To and the default value is 0.0. And let's see what's the next data type, which is double. Data type name is real values. Keyword is double. Wrapper class is uppercase double. And the size is 8 bytes or 64 bits. And let's see the range for double. Compile, execute. So this is the range for double. And the default value is 0 again. So you might be wondering, what is this E in these float and double data types? This is basically a notation to uh, save space or take less memory to save the range in memory. Let's say, for example, you have a big number. We have 23 zeros and a 12, and so to save the number like this, it takes a large space or memory. So for that reason, it is converted into 1.2 E plus 24. This takes less number, or less pace, sorry. So E represents 10 to the power of 24 into 1.2. That's how this is saved. So that's how the space is optimally utilized. Let's move on to the next data type, which is char, and the data type name is character. The keyword is char, lowercase, and wrapper class is uppercase character, uppercase C character, and it takes 2 bytes for 16 bits, and its range is from 0 to 65535, and the default value is empty string or empty character, sorry. And the next data type is Boolean, and the data type name is Boolean. The keyword is Boolean. The wrapper class is uppercase Boolean. Size is not applicable because we only have 2 possible values, so it's gonna take 1 bit. And range is not applicable, but the only allowed values are either true or false. And the default value is false. With this, we have covered all the 8 primitive data types. So let's see some note points. Note 1. Int age which is integer, so will be 4 bytes. Then byte age, which will be 1 bytes. Both are allowed, but what is the recommended data types for age? So int 4 bytes is too big and it's not recommended. Whereas byte is 1 byte. So byte is recommended for age. Why? Because the age value is almost all the times between 1 to 120. And this perfectly fits in the byte range. If you recollect, the byte range is from -128 to +127. So you don't need to use int for age, you just go with the byte. That's point number 1. Next point is byte b is equal to 100. Byte b is equal to -128. Byte b is equal to -129. Byte B is equal to 127. Byte B is equal to 128. So byte B is 100 and byte range is -128 to 127. This is a valid consideration or example. -128, which includes byte, so it is also valid. -129 is not valid because it ends at 128, -128. Positive 127 is valid, falls into the range. Positive 128 is invalid. So you have to choose the data type based on your uh, variable requirement, whether it falls into that range or not. And node 3, we've already covered, but let's just reiterate default values. For integers, the default value is 0. For real values, the default value is 0.0. For characters, the default value is empty character. For Boolean, the default value is false. Now let's go to the next node point, node 4. Let's see what are the default data types. For integers, we have 4 primitive data types: byte, short, int, log. But what is the default data type for integers? It is int. For real values, you have float and double. Default is double. For char, you only have 1, so that's the default. For Boolean, it's again Boolean. That's the default. And let's see another node. For signed negative to negative and positive values, what are the data types available? We have byte, short, int, long, float, and double. For unsigned, only positive, and the data types are char and boolean. We will stop here and This is the end of Java session 102. We'll continue in the next.